Good morning and good afternoon and good evening, everyone. Welcome to another session of the Moonbuilders workshop, today featuring OpenZeppelin. My name is Kevin Nielsen. I'm a developer relations engineer at Moonbeam, and I want to extend a huge thank you to Kathy for putting together this session. OpenZeppelin builds a variety of tools that help developers to build decentralized applications securely and efficiently. OpenZeppelin helps developers to minimize risk by using battle-tested and thoroughly reviewed libraries of smart contracts for Ethereum and other blockchains. Their contracts are the most used implementations of ERC standards, including the famous ERC20 token standard and the ERC721 non-fungible token standard. OpenZeppelin's suite of offerings also includes upgradable contracts and Defender, which you'll likely hear more about today. So this morning, I have the distinct pleasure of introducing two of OpenZeppelin's finest. Jonathan Alexander is the Chief Technology Officer of OpenZeppelin, where he leads product strategy and development. Santiago Palladino is the lead developer and security researcher. He also wrote a book called Ethereum for Web Developers. Before we get started, just a quick note on questions. Jonathan and Santiago have mentioned that they can periodically pause for questions, so you don't have to wait until the end of the presentation. Please put them in the question box at the bottom where it says ask a question. And if you put them in the chat, we'll also try to combine them into that. So with that, I'll hand it over to you, Jonathan and Santiago.
Thank you very much, Kevin. I think we are going to today present mainly we're going to try to focus on some demonstration of the products that we have and the things that you can use when you're building. And we're going to use some examples and we'll show some slides in that. I am Jonathan, and I'll be turning it over to Santiago in just a minute. But just to say a few things up front. First of all, we're very happy to be here, very excited about Moonbeam and all the work going on in Polkadot. We are big believers and supporters in a multi-chain world and a multi-chain future, and we really think there's a lot of opportunity to take work that and experience that we have and that teams have and build out stronger multi-chain solutions, and we think Moonbeam is providing some great capabilities for that. Just to say a little bit more about OpenZeppelin and what we're going to show today, as was just mentioned, our focus is on security. Our mission at OpenZeppelin is to protect the open economy. And in our security work, we provide products that we are going to discuss today, and we also provide security audits and reviews. We've worked with over 200 projects directly in the space. This is a small set of some of those. A lot of projects you would know, and we work in a variety of technologies. You can go ahead to the next slide, Paula. Thank you. So we're in addition to the audit work we do, and if you're interested in audits, that's something you can go to our website and find out information about. We'll talk a little bit today using contracts, using Defender. If you use that early on, this is going to, part of what they do is help guide you to best practices, and that will help you if you are anticipating audits, whether you're going to be audited by OpenZeppelin or someone else. So there are kind of best practices and guides and information in all our documentation that's meant to gear you there. But the other thing I want to mention, I think you may be well aware, for people who are working in the space, that security audit firms are completely overwhelmed with demand right now, including OpenZeppelin. So plan ahead if you want audits. Plan your timing ahead. But we also, as part of the work we do, we provide OpenZeppelin contracts, which we're going to discuss and show you today. And that has been downloaded now well over 4 million times. We know that there are thousands and thousands of projects that use OpenZeppelin contracts. And then we last year introduced OpenZeppelin Defender, which we're again going to get into today. And OpenZeppelin Defender is going to help you with secure operations, taking best practices and needs that we have gathered from many of the leading projects we work with. We have over 4,000 users now on OpenZeppelin Defender. We have many, many of the leading project teams relying on OpenZeppelin Defender. We are happy to say that contracts in Defender are now completely supporting Moonbeam. That's been something we've been working on with the Moonbeam community for a while now, and we're going to be happy to show you that today. So with that, I'm going to turn it over to Santiago, and we'll get started in looking in that more detail.
Thank you, Jonathan. So let's start with the development. And we're going to start with a brief overview of what's within OpenZeppelin Contracts. So OpenZeppelin Contracts is a suite of Solidity building blocks for building smart contract systems. And there are quite a lot of contracts inside the box. This is all open source, free to use. It has been thoroughly reviewed by the community. We have audited an earlier version of OpenZeppelin Contracts and are working with an external firm on renewing an audit for the latest version. But the idea is that you can use these as secure building blocks for building your system. That way you don't need to rewrite many of the common implementations, whether it's ERCs or building blocks for your system. So to try to digest this a little bit, all the contracts that we provide as part of OpenZeppelin Contracts fall within some of these categories. Probably the most widely used ones are the implementations for some of the most famous token standards, as Kevin was mentioning earlier. We have canonical implementations for fungible tokens, non-fungible tokens for the 2021, SEN 7, and 1155 standards, plus a couple of extensions for each of them, which we're going to look into in just a couple of minutes. We also provide building blocks for managing access control. In particular, we provide a library for role-based access control that we're also going to use during the demo today. The idea is that you can use this to control which addresses or which sets of addresses have access to different methods within your contract. We also provide proxy contracts along with plugins for Truffle and Hardhat for managing them. These proxy contracts allow you to deploy contracts that are upgradable. We provide support for meta transactions. So if you want to set up a relayer for sending transactions on behalf of your users so they don't need to pay any gas, you can easily do that using OpenZeppelin Contracts. And a couple of utilities around cryptography, whether it is simplifying access to ECDCA, Merkle proofs, interface detection, or sign type data, or security, such as the widely used reentrancy guard, emergency pause for a contract, or pull payments. And coming soon, probably in a couple of weeks, we're also adding governance into the mix. So stay tuned for on-chain governance as part of OpenZeppelin Contracts. Now, I understand that this may be a lot of moving pieces. And so to make it easy to get started with OpenZeppelin Contracts, one of the tools we provide is the Contracts Wizard, which you can use by heading on to wizard.openzeppelin.com. And that's exactly what we're going to do now. So the Wizard is an interactive tool that you can use for building an ERC20, SEN 21, or 1155 token. We're constantly adding more contracts into the mix, but we always start with the most popular ones. The idea is that you can use this tool for tuning your contract, such as with simple stuff, such as choosing your name, choosing the symbol for the contract, my contract, where it is, defining, for instance, a pre-mint account, and toggling features that you want to include in your token. So, for instance, in the case of an ERC20, you can choose the contract to be mintable. This means that it's possible to dynamically mint and create new tokens, in this case, only by the owner of the contract. So if you choose mintable, the wizard will automatically include a public mint method that you can use for creating new tokens. same as possible, for instance, in which case the wizard will automatically import the necessary code, and have methods for issuing an emergency pause on a contract that will disable all token transfers when the contract is paused. This allows you to shut down all operations for a period of time in case you detect a hack or an emergency situation, giving you time to react and, let's say, upgrade the upgraded token contract, or somehow fix the issue that you're dealing with. Again, we support several different features. We're not going to go into each of them one by one. I encourage you to check the documentation at docs.openzeppelin.com/contracts. There you'll have an extensive guide on all the different moving pieces that we provide, as well as the API for each of the contracts, including the details and explanation of what each extension is about in each of the contract standards. A few other interesting things that you can access through the wizard is, for instance, tuning how you want to manage access control. So the simplest thing you can do is set up an ownable contract, which means that there will be a single address that's assigned as an owner of the contract that has rights over all administrative actions, such as pausing the contract, minting it, or whatever administrative action you want to deal with. Or you can opt into the more interesting access control extension, which will issue role-based access control for the different methods. So the way role-based access control works is by defining different roles for the different kind of permissioned actions in the system, and using these modifiers to specify what each role can do within the contract. So instead of having a single address that has absolute control over your contract, you can define a set of addresses that are allowed to mint new tokens, and that can be a completely different set of addresses that can issue an emergency pause on the contract. For instance, you could have an automated hot wallet for minting contracts in response to an automated event, and you could have the pauser role managed by trusted developers within the system. Last interesting part that we're going to highlight here is that you can opt in for upgradability. If you do that, again, the wizard will automatically include all the necessary base contracts. And we'll also switch from contracts to the contracts upgradable library, which is a fork that works nice with upgradability. You can also choose between two different flavors of upgradability. Transparent is maybe the simpler one, but it's also more expensive in terms of gas. UUPS is one that we launched recently that we encourage you to use, since it's a bit more lightweight than the transparent option. So what we're going to do for the demo today is actually we're going to deploy a non-fungible token. Let's say that this is going to be the Moonbase NFT. And we're going to create a mintable ERC721. So the idea is that someone who has the minter role in this contract will be able to create new tokens just by calling the mint method. And we're also going to opt in into auto-incremental IDs. So instead of having to track which are the latest IDs generated outside the contract, we can have the contract take care of that. We could also add a enumerable extension since we're at it. Let's make it possible as well. Note that when we check possible, we also get the pauser role defined. So we have on one hand the addresses that can pause the contract, on the other the addresses that can mint new instances. And as you can see by default, these are all assigned to the account that's going to deploy the contract. So now that we have the code ready for a non-fungible token that can be paused and that can be minted, we're going to deploy it. And for deploying it, we can either just copy this code and move it to a Traflow or Hardhat project. But for the sake of it, we're just going to open it in Remix. So for those of you not familiar with Remix, Remix is an online IDE that you can use for building, compiling, debugging, and also deploying contracts on different networks. By default, Remix is going to work on a local network that runs within the browser, but you can also, using MetaMask, connect it to to a different network. It seems like Remix is a bit slow today. Let me see if I try again. If I get it to react, of course, Remix usually works fine, except when we're on a demo. But the idea is that you can use Remix for compiling the contract and connect Remix to MetaMask in order to deploy your contract. Let me try to access Remix directly to see if we have better luck. But it seems that right now Remix is deciding not to respond. Apologies for that. Okay, maybe we can try this a bit later. I have a contract that I have already deployed, so we can work with that if necessary. Anyway, another thing that we provide besides contracts themselves are plugins for Hardhat and Truffle for deploying contracts in an upgradable way. So, for instance, something we could do instead of relying on Remix is build the ERC721 using the OpenZeppelin Wizard, download the code into an existing Hardhat or Truffle project, and use one of the upgrade plugins to deploy it in an upgradable way. Sorry. So what we can...
Paula, I was going to say that I'm just testing Remix, and it looks like they put something new in front, but it may be, you could give it one more try if it's...
Okay, let's see.
We'll see. There you go.
Okay, this one is loading. Let me actually export here.
Let's see if we can get it loaded.
Yeah. Okay, yeah, it seems like it doesn't want to load the code. Funny thing is, this was working literally half an hour ago.
Yeah, it looks like
anyway.
They just put something up there. Okay, sorry, go ahead.
Okay, never mind. Still, maybe I think that I have the contract from the previous run. Let me see. Okay, anyway, let's carry on. So, moving on with upgradable contracts, you can check out the documentation directly on the upgrade section. You'll have access to resources around the upgrade plugins, how to write upgradable contracts, and also how to manage upgradable contracts using Defender, which we'll see in a minute. The main thing you want to focus on is on the upgrade plugins, which allow you to manage them from Hardhat to Truffle. The idea is that these plugins give you access to deploy proxy and upgrade proxy methods, among others. And you can use this for deploying a contract in an upgradable way. So what this method is going to do under the hood is it's going to validate that your contract can be upgradable. Keep in mind that if you want your contract to be upgradable, there are a couple of caveats around how you write it. We have a section on that also if you're curious. Long story short, you need to avoid a couple instructions, and you also cannot use a constructor. So the deploy proxy instruction is going to validate the implementation contract. It's going to deploy it on chain, also create a proxy that's pointing to that contract. So whenever you want to upgrade to a different implementation, you call upgrade proxy with the instance that you have deployed earlier, and the new version, the new implementation that you want to upgrade to. And this method is going to, once again, validate that the upgrade can be safely made from one version to the other. You can only do this if the storage between the two versions are compatible between each other, which is something that the plugins will automatically check. And then update your proxy so it points to the new code. That way, you retain the same address, the same balance, and the same state in your contract, but you change the code to a different one, which you can use for fixing a bug, adding a new function, or modifying a feature as you need. Okay, so let me give just one more shot here. Let me actually remove a couple of features, see if that's why Remix is complaining. But it seems not. Okay, never mind. We can play with the contract already deployed. So, do we have any questions so far before we move on to Defender?
I don't see any entered. And if anyone in the audience does have questions, please enter them in the chat or click on Ask a Question and we'll take them as we go. But you can keep going.
Awesome. So, As Jonathan was mentioning earlier, Defender is a platform for automating secure operations on smart contract systems. And we're going to go through Defender today playing with a case study. And what we're going to do is we're going to use Defender for managing our contract, for monitoring basically the contract, the SN21 contract we wrote on with the wizard. We're going to monitor activity on the token, and we're going to automate the minting of new tokens. We're going to do that using Defender. You can head over to defender.openzeppelin.com. You can create a testnet account for free and start using it right away. And the idea is that Defender will provide you with different components for managing and automating operations on your contracts. So what we're going to do today is we're going to use Defender first for creating a secure hot wallet for minting new tokens. Remember that the NFT contract we set up has a minter role that can be used for minting tokens. So what we're going to do is going to create a hot wallet that will have this role and will be able to mint tokens on demand. And we're going to automate the process. We're going to set up a task that on a regular basis, it's just going to mint new tokens as it goes. Last but not least, we're also going to set up monitor functionality just to stay on top of all transfers that happen on our token contract. So let's get started with Defender. And we'll start, as we mentioned, by creating a new hot wallet that we'll be using for sending transactions. We're going to use, let me enlarge this a little bit. We're going to use Defender Relay for that. So Defender Relayers are private keys kept on a secure key vault by Defender so that you can use for automating the process of sending transactions. We're going to go ahead and create a new relayer. So this is going to be Moonbase 2. It's going to be Moonbase 2 because I already have a Moonbase relayer. And we're going to set up this on the Moonbase Alpha network. So by creating a relayer, what's going to happen is that Defender is going to create a private key to be used by our team. By the way, you can invite as many team members as you want to Defender that will share access to everything within the system. And for that private key, we'll derive the address that will be used by this relayer so that you know that you have exclusive control over this address. Any transactions you send using this relayer and Defender will be sent from this address. So you can trust this address, and you can also appoint any secure roles that you need for this address to interact with your system. In this case, we're going to assign the minter role to this Ethereum address. Defender is also generating an API key and secret that we can use for programmatically interacting with the relayer. So we could set up a script that sends transactions using this relayer instead of using a local private key. And to authenticate there, we'll use this API key and secret pair. You can create as many API key and secrets as you want, and all the while keeping control of the same Ethereum address. This is just, think of it as a user password used to authenticate in Defender. These are not the Ethereum address private key. The private key is generated within a key vault, and it never leaves the key vault. So something else we're going to do is going to send some funds to this relayer so we can start using it right away. I'm not sure if you can see my my MetaMask pop-up in the yeah, you can, perfect. So I'm just going to send a transaction with a little dev so we can start using this right away. And I'm also going to switch into a different account that we have been playing with. Okay, so we have a hot wallet within Defender. Now it's time to use it for actually minting tokens in the NFT contract that we have been working with. So remember, we have this address E330 that's assigned to us, and we have full control over it. So what I have is a script that I have written earlier that uses Ether.js for interacting with the network. And basically what the script does is it just uses Ethers with a signer. A signer is an Ethers component that takes care of sending transactions, and just calls the safe mint contract by minting tokens to a recipient account that we have defined earlier. The idea is that we're going to use this snippet of code connected to the Defender relayer using, in this case, the Defender Relay client library that we provide in order to send transactions using the relayer. And for running this code, I could either run it locally in my local machine using the API key and secret for authenticating on the relayer, but instead I'm going to use an autotask for interacting with the interacting with the relayer. An autotask is just a function that runs within Defender, and actually I'm going to use an autotask that I had defined earlier. And this autotask has the code that I just shared with you. As you can see, this is the address of a token I had deployed on a previous iteration, fortunately when Remix was working fine. And it's just going to mint tokens to this address whenever this autotask is executed. So the idea is that autotasks allow you to submit snippets of code in JavaScript, and Defender will take care of running it on your behalf. And when is Defender going to run these snippets of code? You can manually run this code whenever you want, just by executing it here within Defender. And this will take care of executing all the logic that you have defined. For instance, in this case, it's minting another token for the address we have defined in this transaction. We can actually go here to the Moonbeam Explorer and check this transaction. Oh, sorry. Here we go. Okay, still loading. Here we go.
Just a second for the transaction hash to get picked up.
Exactly, yeah. Here it goes, but as you can see, this is a transaction for a token minting on token ID 91. We have been minting quite a few tokens already. And as we can see, this was actually sent from address 0xC03, which if we go back to the autotask we were playing with, we'll see that this autotask is connected to a Moonbase relayer that I had defined earlier, and I'm actually going now to connect it to the Moonbase relayer 2 that we have been working with. So this allows you to connect the autotask to the relayer so that whenever you send a transaction from your autotask code, it will be sent using the relayer that you have defined earlier. That way you don't have to worry without any kind of authentication on the relayer. Everything happens within Defender. And you can choose the autotask to run on a scheduled basis. For instance, here I have instructed Defender to run this autotask every hour. So every hour there is a new token being minted in our contract. Alternatively, you can also choose to set up a webhook, which will return a unique URL that whenever it receives an HTTP post, it will mint a new token, and you can use this for integrating with third-party systems or just in general integrating with any other parts of your application. So note that we have changed now the autotask to use the relayer we created just a couple of minutes ago. And if we run the autotask now, I would expect it to fail because this address should not have rights to mint tokens in our contract. So what we're going to do now is exactly that. We're going to run a grant role action in our contract, basically an administrative action that allows us to grant a role to a different address in our contract. To do that, we're going to use Defender Admin. Defender Admin is an interface for managing your contract. So whenever you need to run a management function, such as assigning new roles to your contract, issuing an emergency pause, upgrading it to a different implementation, changing the parameter, you can use Defender Admin for that. Defender Admin does not have any control over your contract. It's just an interface for you to easily manage your contract instead. So I'm going to go with the NFT I had deployed earlier, which I had already added to Defender. I'm going to create a proposal for an admin action. An admin action is invoking any kind of action, basically calling any function on our contract using Defender Admin as an interface. And what we're going to do is we're going to choose the grant role function. And what we're going to do is we're going to pick the minter role, which is defined by this constant. We're going to assign it to the Moonbase relayer that we have just created. Defender admin allows us to send a transaction in different ways. For instance, we could use a multi-sig wallet for sending a transaction. We could also use a time lock in case we want to enforce a delay between the time this proposal is approved or not. But for the sake of this demo, we're going to go sending a transaction directly from our wallets. And the last bit here is we're going to explain what we're doing, what administrative action we're doing, so that other team members can review it and this can provide a trail to understand all the changes that you're running on your contract. So for instance, we are granting the minter role to the new Moonbase relayer. And I'm going to go ahead and create an admin action. This is going to validate that the action can be correctly executed, which I can because this address is an administrator of the contract we're working with. And before executing this action, I have a chance to review it, understand how it's going to be executed, which function is going to be called. And the idea is that if you're running this, for instance, via multi-sig, where you require approvals from multiple team members before it can be actually executed, they have a chance to review the proposal, understand what it is about, and decide whether they want to approve it or not. So we're going to confirm this action, and this is going to send a transaction from our current address to the NFT contract. That's going to grant the minter role to the relayer that we have just set up. So now with that role being set up, we should be able to go back to the auto task that we were earlier working with. And let's see, we have this earlier failure. If we run the auto task again, if the grant role transaction has been already processed, we should be able to mint the new token. Here we go. So as you can see, we have minted an NFT for this address in this transaction. If we go back here to the block explorer, as soon as it's picked up, we need to refresh a couple of times, but what we will see is that this transaction was sent from the relayer that we have just created. Okay, it's taking a couple longer than I would have liked, but the idea is that here we go. So you can see this transaction was sent from address E330888, which, if we go back to Defender, is the address of the Moonbase relayer we have just created. So to provide a recap of what we have done so far before we move on to the next component, what we have done is for an NFT contract that we have written using the wizard and deployed to the Moonbase network, we created a new relayer, which is a private key hosted by Defender, which you can use as a hot wallet for sending transactions, which not only provides security by keeping your private key on a secure key vault, but it also takes care of automatically resubmitting transactions in case they don't get mined, broadcasting them across several network providers, managing nonces. So if you're sending multiple transactions in parallel, you can rest assured that you won't have any clashes in nonces. And in general, simplifying the process of sending a transaction. The idea is you can just tell the relayer which transaction you want to send, and the relayer will keep monitoring that transaction and make sure it gets mined on the network. And if not, it will keep resubmitting it until it actually reaches the blockchain. So given that address that we set up using the relayer, next thing we did is we created an auto task, which the auto task is a snippet of code that interacts with this relayer and instructs it to send a transaction for minting a new token, in this case to this recipient that we had defined earlier. And the idea is that you can inject any logic here. You can query other contacts for more information. You can query external APIs if you want. You can define whatever logic you want. We also provide a small key value store that you can use for temporarily storing data between autotask runs, and also a key value secrets vault that you can use for, let's say, storing storing any kind of secret keys that you need, for instance, for accessing external APIs. For instance, I have GitHub tokens stored here that I use from Autotasks in order to interact with the GitHub API. And the last thing we did was we used admin in order to, from our account, that's the admin of the NFT contract, grant the minter role to the relayer that we had created earlier. That way, the relayer has access to our contract and can mint this transaction, has this privileged role that allows it to mint any new transactions. Do we have any questions before we move into the last component in Defender?
I think we're still good. So
awesome.
Let's keep going.
Okay, let's go then onto Sentinels. So Sentinels is a component that allows us to monitor new contracts, monitor transactions on our contracts on Defender. I'm going to create one from scratch, even though I have one already set up. Transfer to. This is running on Moonbase Alpha, using the Moonbase NFT I have deployed. I want to pick up the ABI, which I don't have because Remix is failing. So allow me actually to go back to the Santiago I have defined earlier. Apologies for that. So for creating a Sentinel, what you need to do is define the contract that you want to monitor. And from there, you can define conditions to decide what you want to monitor on your contract. So for instance, you can define conditions on the transactions themselves. For instance, you could choose to monitor only transactions where the status of the transaction was successful, or transactions where the value transferred is greater than a certain number. And you can also choose to monitor specific events emitted by your contract. So in this case, since we're interested in monitoring transfers, what we're going to do is we're specifying that we want to monitor the transfer event, and we're going to add a restriction that we only care about transfers. We won't monitor any minting events. So a mint will emit a transfer event where the from address is the 0 address. So we're going to pick every transfer where from is different from 0. This way, we'll know whenever there is any activity on our contract and whenever a user is transferring a token onto a different one. We can also monitor direct function calls to the contract, and we can also set up auto tasks here. So if there is any complex condition that you need to run, or the syntax is not enough for expressing what kind of things you want to monitor, you can also connect a Sentinel to an auto task that will be called whenever there is a transaction that may be picked up by the Sentinel, and you can run your own custom logic to decide whether that transaction should be picked up by the Sentinel or not. In this case, we want to do something simple. We just want to look for transfer events that are not mint events, this is, that are not sent from the 0 address on the NFT contract that we have just set up. And the second, yeah, go ahead.
And just a quick question. Oh, if you don't mind. And why are you checking for if the address is not equal to the 0 address?
Basically, what I want to do is monitor transfers between two users. If the sender of the transfer is the 0 address, this actually means that it's a minting event. That is, that this is a new token that was created, probably from the Autotask and relayer that we set up earlier. So this is how the minting event is specified, both in ERC20 and SEN21. So whenever a new token comes into existence, what the contracts emit is an event that says, hey, this token came up from thin air. So it was transferred from the 0 account. This is no one, because no one held the token before. And it was sent to this new user, this new address. So here, since I'm only interested in transfers between two different users, and I'm not interested in new tokens being created because I'm the one controlling that via the auto tasks, I'm specifying that the sender should not be the 0 account. Okay. Do we have, not sure if that's clear or we have any other questions?
That's perfect.
Awesome, thanks. Okay, so here we define what do we want the Sentinel to look for. The second piece of the puzzle is define what we want the Sentinel to do whenever it picks up one of these transactions. And what we're going to do is we can actually define several different actions. We can have the Sentinel send us an email, a Slack message, a message via Discord, Telegram, send this to data log for aggregating data. Here I have a couple of channels already defined, so I'm going to choose email, Telegram, and Discord. Not only that, but we can also have the Sentinel trigger an auto task whenever it sees a transaction. So in particular, what I'm choosing to do here by picking the Mint Moonbase NFT auto task is I'm telling the Sentinel that whenever it sees a transfer between two users, I want it to send me an email, Telegram message, a Discord message, so I know that a user has sent their NFT to another one. But it will also mint a new one. So whenever a user sends an NFT to another one, I get another one for free, just for the sake of it. We could also define some additional conditions on when we want this to trigger. For instance, we may only trigger this whenever there have been 10 transactions within 15 minutes, but we don't want to go there. We just want to execute this on every single transaction. And I'm going to save the changes here. So now what's going to happen is whenever a user sends their NFT to a different user, it's going to send me an alert and trigger a transaction. So for instance, if we go back here to this minting that we ran earlier, we see that we have token ID 92, and it was sent to address F089, which is in my control. So let's move token 92 and see what happens. We could use any wallet for this, but to make it simple, we're just going to use Defender admin again. You could argue that this is not actually an administrative action on the contract, but still, we can also use admin for regular contract calls. And so what we're going to do is we're going to send from address F089, which I have already logged into Defender, to, I don't know, some other address that we have here. And we're going to try to move token 92. Are there any questions?
Yeah. Does OpenZeppelin run nodes to broadcast transactions, or how do they get broadcasted to the network?
We actually connect to different transaction providers, network providers for both querying and broadcasting transactions. In this case, since the transfer transaction is going to be sent from my MetaMask, let me start running this so we can see that. This is going to be a transfer. Actually, if I have control of this token, probably yes. Yes, I do. So whenever I'm going to send this transaction is going to be sent through my MetaMask. So whatever provider I have designed, since it's signed by a wallet in my control, in my browser, and sending it via whatever provider I have chosen. For transactions sent via relayers, which are the ones sent automatically by Defender, for instance, all the minting transactions we have been seeing, Defender connects to multiple network providers so that if one of them goes down or there is an outage or even a chain split, you can rest assured that your transaction will reach the network because we're trying several different network providers at the same time. We work with public network endpoints, also with proprietary network providers that gives us access to all the different networks, including Moonbase. So we have executed the transfer. It should have been already minted. Okay, we're here connected to the Legacy Explorer. Let's actually check this out on Block Scout. So whenever this is minted, and it already has 3 block confirmations, if we go to Discord, we see that from just 1 minute ago, we received a message from Defender that the Moonbase NFT transfer Sentinel was triggered by a transaction on the address of the contract we were working with this transaction hash, AX3, which we see that matches the one we just saw. and triggered by a transfer event where the sender is not a zero account, but the account from which we just sent the transaction to whatever other address for moving this token. I also got a message via Telegram, another via Slack, and I could also have received an email if I chose to. And the other interesting thing is that in response to this, if we go back to the auto task we had defined earlier, we should have from exactly just 1 minute ago, triggered by a Sentinel, a minting action. So what's happening here is that in response to that transfer, we have executed this action that has minted yet another token for the beneficiary address that we have appointed. So to recap, since we have a bunch of moving pieces here, what we have done is we have set up our ERC SEN21 contract that whenever there is a transfer, it's going to emit a transfer event. And that event is going to be picked up by a Sentinel that we have defined. That Sentinel can send notifications or push data to wherever we define, among emails, Slack, Telegram, or Discord, or pushing data to Datadog. But in addition to that we can use that for data aggregation or notifications, we also connected it to an auto task. The auto task, again, is a snippet of code that you define that runs whatever logic you choose. And in this case, we choose to set it up to mint new tokens on the contract. And the way it's going to do that is via a relayer, which is a hot wallet that's stored on a secure key vault within Defender that's going to call the mint method, the mint method on the SEN21 contract. And in order to be able to call this mint method, first we need to use admin to manage the role within the SEN21 contract so that our relayer has the minter role needed for calling the mint function. So this way, you can use all different Defender components for monitoring your contract, for reacting to it by executing any custom code, either triggered by a transaction or on a scheduled basis or via webhook, and use an address that's controlled only by you to interact back into your system. You could be sending transactions either to your contract or to a completely different one. And remember that the Autotask can do any action you want. You could also use it to update an internal system of yours and not even send a transaction in response to a notification. And also keep in mind that you can use admin not just for calling arbitrary functions, but also for managing upgradability, for issuing emergency pulse in the system. And you can do that via time logs or multi-sig wallets as well for additional security. So before we move into the very, very last thing in the workshop, any questions?
Let's go ahead and wrap up. There may be a few lingering things. But
let's make it quick. The last part that we want to share from Defender is Advisor. Advisor is a knowledge base that we have packed within Defender that has best practices that we have been accumulating over years and years of auditing and developing secure smart contract libraries. These are best practices for development, testing, monitoring, operations of smart contracts, tagged depending on their rating and their level of effort. And the idea is that you can use this knowledge base to search on any topic that you want to learn more about, and Defender Advisor will share with you all the relevant documents with explanations of the security controls and the protections that you want to implement, including which patterns you can rely on, which code snippets you can use, some concrete examples in different contexts, and basically all the information you need to learn more about all these security controls. Again, you can use Advisor for learning about best practices for security in your system, which is very, very good preparation before an audit. So with that, I think that we're done for the live demo. Let's pick up what other questions we have.
Amazing. So we have a couple questions to start. So you mentioned, the OpenZeppelin audit practice, and I was wondering if you could highlight maybe what issues do you commonly see there? What comes up frequently in an audit?
Sure. So we see many different things in an audit. One thing that I'll mention that usually removes many issues is avoid reinventing the wheel. So we provide OpenZeppelin contracts for a reason. These contracts have been reviewed a lot of times. They have been vetted. They have been audited also in previous versions. And it's a good practice to reuse these building blocks rather than rolling them your own. So instead of, we have seen many failed or buggy implementations of common standards such as ERC20 or SEN21. And those are bugs that could have been prevented by using trusted building blocks. We also see some issues that are independent of the implementation themselves, such as integrations with other systems or also economic issues. We have an ongoing series on secure development by Martina Batemarco, one of our top security researchers. So we strongly encourage you to participate in those. The last session was about the perils of integrating with ERC20 tokens, so unexpected behaviors on tokens you're interacting with. I strongly encourage that you participate to have an idea of what things you need to have in consideration when, say, developing secure smart contracts. Jonathan, not sure if you have anything to add.
Yeah, I think just a couple of things I would add is that if you're developing new smart contracts, as Paula said, we've seen many teams try to kind of rework or rebuild, and there are often implications that teams don't take into account. So you want to be really careful about modifying templates that you are working from. And the other thing is that in the rush to deployment, I think many teams, are focused on value and delivering value, but to deliver security, you often need to be very careful, and you may want an audit or external review. So think carefully about spending time on your documentation and your tests, because the documentation and tests are going to be very valuable input to outsiders who will possibly be able to come in and give you advice and look for, potential exploits. So in terms of preparing for an audit, design documentation, code documentation, and tests are super valuable.
Awesome. That was excellent. And we covered both, getting ready for an audit, but then also, what we see in an audit. And so you hinted at it earlier in the presentation, but could you speak to, upcoming features, what's in the pipeline for new things?
Sure. In terms of contracts, we're working on new governance contracts, on-chain governance, which you'll be able to use for further decentralizing governance of your project. And that we're also adding support for that within Defender admin. We're also adding further support for time logs, for creating your own time logs from Defender. And we're also working on several improvements to relayers and autotasks across the board.
Yeah, I think in addition to those, the whole area of security monitoring and threat detection has continued to gain interest. For those of us who follow the space, we know that there are weekly reports of exploits and losses. And so you're going to hear new things from us in the topic of threat detection. And we are very interested to continue to provide transparency. We think one of the key advantages of having an ecosystem in communities is the extra security it provides, but we have to enable everyone to contribute to projects and work in a decentralized fashion. And so you'll continue to see us as we move into this area of governance. Also, we'll continue to work on transparency and enabling decentralized contributions to the security of the space. So Highly, if you're interested in all this, we do regular educational workshops, technical workshops for free at OpenZeppelin. We're super happy to be invited here today and contribute, but you can also watch our blog for information about upcoming events. And Paula just mentioned a couple of them that we have ongoing series.
I'm especially fascinated about the threat monitoring. That's very, very interesting and needed. And you mentioned you have the technical workshops, right? We have at least 1 or 2 students here. What would you suggest for how we can maybe bring more, developers into the Web3 space, which, at first glance can be, somewhat intimidating, perhaps?
Sure.
Do you want to start, Paula? Go ahead.
Couple of things. I think the first thing is make Web3 as accessible as possible and gear education to traditional Web2 developers. There are a lot of Web2 traditional developers out there, and the leap to Web3 is not that difficult for a developer that's also already familiar with Web2. I suggest going through OpenZeppelin Contracts for getting some familiarity with Solidity. And if you're interested in security, we have 2 games for that. We have Ethernaut and Vulnerable DeFi, which was built by, again, Martin Abate-Marco, who's leading this security development series. So if you're interested in learning a bit more about security in particular and Solidity smart contracts, I encourage you to check out both of them. I'll share the links in the chat in a minute. Jonathan?
Yeah, we spend a lot of our time on developer education and contributing to that, and we are also hoping to enable more developers to move into the space. Other resources we have, in addition to the kind of weekly workshops we do that you can check out at our blog, the games that we have that we've developed, the documentation we write, which you can find at docs.openzeppelin.com, has a lot of guides. The tool we showed earlier on, Wizard, is specifically designed to help people learn about different templates and practices. And then the other thing is you can participate at our forum. We have a public free forum, forum.openzeppelin.com, widely used. And there's a great community there, thousands of contributors. You can ask questions, you can learn. So all those things we do to enable. We will say that incredible improvements in the ecosystem in the last year. It's getting, information is more accessible, tools are improving, platforms like Moonbeam are helping step that forward. And so I think we're all making progress.
Thank you. And last question I have is what excites you about Moonbeam?
I think it's a great platform for bridging the gap between Ethereum developers and Polkadot developers.
We're so excited to have you.
I think we're really excited about multi-chain. We're seeing things are happening rapidly multi-chain, and we have leading project teams we work with, like Compound, who are building on Polkadot, and the ability to interact and there's a pretty good world of Solidity development and Solidity developers, and to allow them to interact immediately, I think will be super advantageous. So we're excited.
Absolutely. Thank you so much for being here today. Thank you, Kathy, for setting this up. Thank you so much for your time, Jonathan and Santiago. Really, really appreciate it.
Thank you for having us.
It's been a wonderful
Thank
pleasure.
you, everybody. Thank you for setting it up and helping us.
Thanks.
Bye, everybody.
Bye.